Welcome back, my friends, to your favorite math explanation videos. Today we're going to talk about how to add these fractions with the radicals in the denominator. And these look quite nice, and when I first saw it I thought, this is easy. We're just going to use the whole, conjugate business, and we'll be fun. We'll be on our way. And then I realized that the denominators are not the same, and that just makes it a little more cumbersome, which sucks. But that's part of life, and we have to learn and embrace the cumbersome nature of some math problems. In fact, if you want to go anywhere in calculus, you have to just learn to love the complete page problems that take 25 steps to simplify. And you just have to get, it's part of the mental stamina. It's not super fun, but you just learn to love the drudgery of line-by-line calculation. Whoops. And I must say, it ends up becoming quite fun. Yes? Mm-hmm. What? Yeah. So we have this right here, and we're going to, I guess we will multiply by the conjugates. I'm just going to give myself some space here. And we will multiply this one right here by root 8, which, by the way, is, oh my gosh. You know what? Forget the conjugate. Root 8 is just 2 root 2. What are we doing here? This right here is really, I don't need the equal sign. I'll fix that later. This is really 2 root 2 plus root 2, isn't it? Okay, so this is really 1 over 3 root 2. And this one over here, I'll make it purple, minus 3. That's 2 root 2 plus 3 root 2. That's 5 root 2. Right? Root 8 is 2 root 2 plus 3 root 2 is 5 root 2. So I get that, and you know what? I'm almost there. If I just multiply this by 5 over 5, and this one by 3 over 3, I will get the same denominator on both, which is 15 root 2. And this will be 5 minus 9 on top. I hope you agree. Which is negative 4 over 15 root 2. And yes, we do have to get rid of that radical. So we will do that now. And that then becomes minus 4 root 2 over 30. And lo and behold, they're both divisible by 2. So we have minus 2 root 2 over 15. Wasn't that lovely? No conjugates required. So, hooray! It wasn't as hard as we thought. And that's math too sometimes. Sometimes before you bring the battering ram, make sure the door is not unlocked. You know, just try to see if the problem is difficult or not. So,
I have a question.
yes, what's the question?
How did you get 5 over square root of 2? Please, 5 square root of 2 right there.
This one right here?
Yeah.
Good, yeah. So you're right. I did go a little bit fast on that. So the question was, how did I get 5 root 2? And basically I said that this right here and this right here is 2 root 2 plus 3 root 2. And that adds up to 5 root 2. And that 5 root 2 became this one right here. I just went a little quick with the simplification.
And then why did you multiply it by 3?
So I multiplied this one by 3 on the top and the bottom because I want to have a common denominator with this one on the left. And I realized that this one had a 3 and I needed a 3 over here, and this one had a 5 and I needed a 5 over here. So I multiplied by the missing factor in order to make the denominators the same. And once I did that, look, they both had a denominator of 15 root 2. And once I did that, I was able to subtract the numerators. And that's how I was able to simplify that. Excellent question. Thank you. All right, last question. Number 6. We have time. Yes, we're going to do it. We have to move a little quickly, though. This looks cumbersome. This looks like not a lot of fun, which is exactly my kind of problem, which is exactly the kind of stuff I want to embrace. So I think the easiest thing to do is to pick out some squares and to start simplifying those squares, and maybe the problem will look a little bit easier. Because right now it looks like a mouthful, a handful. It just looks messy. So what I mean by that is instead of root 40, how about 4 times 10? Let's go ahead and break that down to its factors. Instead of root 12, how about root 4 times root 3? So in other words, 2 root 3. And why don't we just use some different colors? Plus 3 root 5. Root 48, well, that's 16 times 3. So that's times 4 root 3. Okay, so root 48, I'm saying, is 4 root 3. Root 48 is 4 root 3 because 48 is 16 times 3. And 16, the square root of 16 is 4. And then we'll move on to the next one. Minus, okay, so 4th root. This is 25 times 3. There's really, oh, do I really have to go there? I better do it fast. Okay. Well, what is a 4th root? Well, 75 to the half is the same thing as 75 to the 4th root, or 75 to the quarter. Remember, the denominator indicates the root. The denominator of the exponent indicates the root. But I could rewrite this as root 75 and then the square root of that. Which I will, which I can. And so that's what I'll do. So this is minus 2 times the square root. Now root 75 is 25 times 75 is 25 times 3. So this is really 5 root 3. What a tangled web we weave. And what a mess. Are we running out of time?
No, we got 4 minutes.
Well, what I can do is I can dismiss you guys and then I'll just keep going with the video. Because since you guys don't, it's just, you'll, bye, Mr. Schomburg. You just keep teaching. We're going to go home. Okay, and all this equals 0. Wonderful. This is a lot of steps.
Wait, how did you get?
He gained all the time.
Wait, 3 square root of 3?
Yeah, 27. Root 27 is 9 times 3. And so that's 3 root 3.
Oh, yeah.
Yeah. Okay. All right. So in the interest of time, I'm going to speed this up a little bit. So 4 times 10 times 2, that, of course, is 80. And 80 is 16 times 5. So this is really 4 root 5 root 3. And then the purple part plus, so this 4 can come out. So this is 6. So 3 times 2, why 2? Because square root of 4 is 2. So this is 6 root 5 root 3. Hey, I'm seeing a pattern. I really hope it holds. Sometimes they are mean, though, and they don't hold the pattern.
So 5 root 3.
Minus 2 times root 5 root 3, right? So you see the pattern? We're having, we're on a roll here.
Hey, your head.
Am I going to make it?
It's just the same thing
Yes, very good.
Schellenberg, I think you messed up.
I did not mess
On
up.
the first one, on the blue one,
Yeah.
it's supposed to be 8, not 4. You have the 2 outside.
It's 80 root 3, and 80 is 16 times 5. And 16, the square root of 16 is 4. That's how the 4 came out in the blue one. Yeah, so it is quite correct. All right, 15 times 3 is 45, and that's 3 root 5. So this is not minus 4, but minus 12, because we're going to take that 3 out. Root 5, root 3. And now we are almost home, my friends. So we have 4 plus 6, which is 10, minus 2 minus 12. Hey, I messed up on a sign, did I?
On the one I told you.
Are you right? Oh, you're right. I forgot the 2 in front. You are correct, my friend. So this is really... Oh, because it got covered up by the drawing thing here. It got covered up by this little panel. That's why I messed up. So we'll just make that 2 times 4 into 8. And now we have 14 minus 14 is 0. Yay, we did it. Hooray.